find the index. Right, that's the typical use case. Still an interview question, but I mean, the base is always that how do you create this hash functions, right? How will you find from the input, how do you get a hash function, what data, and how do you derive that, which index where you will store. So typically you end up doing mode of your array size to get the value within the array bound, right? So that's how it really gets into it. Okay. Use case, right? One is password validation for sure. Second is index mapping. Using index mapping. That is just to what we explained you before. This one. This is where I use very heavily, guys. Validating signature of a file. Because since I come from a browser team. Okay.
In the previous slide, that index table size depends on the address space, that bit combination.
Sorry. This
hash table size depends on your bit 128 bits or 256 bits. That combination depends on this.
That combination will depend on this. No. To find the real index, only the mode value will depend on it. Because I want to eventually, whatever the hash value that you get, right? I want to map that hash value to some of the indexes. That indexes can only be possible when you take a reminder of that calculation. And that happens via mode. Right? That's the whole purpose. But 128, 256 will affect? No, it does not affect.
So I mean that number of combination size will be in this index combination?
That combination, no, it is only meant to find the index. It is not meant to store the data in this case. It is only meant, it is finding what data I have to store at what index, but nothing else. Okay, I will get out of okay, right, and so what I was saying is, this is the validating signature of a file, guys. Since my team used to come from this particular module, where anything that you send, we used to do the validating signature of a file to make sure that even from any network, whatever you are doing, any file attachment has to go via hashing. No file attachment ever happens without hashing it. In today's world, no. Okay, and then VPN based. Every VPN uses very heavily. VPN relies only and only on hashing base to validate a signature periodically. I do not know whether how many of you know, just to validate in every 10 seconds, there is a ping pong game happen under VPN to figure out whether the hash is still same or not. This is done very often. Very often. Okay, and why we do it? Anytime your VPN gets compromised, your enterprise security is fully broken. That's the reason the hash code of your existing user will never change until you really do explicit log off call from the machine. Right? So that relies, and that is typically every VPN, no VPN will ever use any sort of non-crypto hashing. Even though it is slow, they'll end up using a secure hashing. Right? So
spam filtering.
Spam filtering, you want to figure out what emails are genuine or looks to be legitimate and what emails are not. But you mean how does they use it, is it? In hashing.
Do you store it in the table or?
So, okay. Yeah, that's one way. But I really do not know.
Yeah, I can help you there. Like, spam emails have a specific structure, right? So if the hash is taken and simply the mail server is keeping that, they can check and you may come if the spam or not.
So there is a repository of spam email pattern?
Yeah.
Okay. So I think you got the answer. Thanks. Yes.
So every file will not be used, right?
Every file.
Already have DLS.
So that's what. So when I say sir browser, I always mean TLS. Yeah.
So
TLS
on
will.
top of that, we will use
On top of TLS for file upload we do it. One more hashing signature we use apart from TLS.
Isn't it an overhead?
Yes. You're right. You mean TLS is already doing it. So TLS is typically doing the encryption at the payload level, right? But we as a browser do it at the app layer, right? So you're right. It is actually twice, but for attachment we do it because of a compliance, and I think this is how SFTP works normally, right? So that may be the reason, but you're right.
I mean, your code is actually valid there because once you get into the application, if you want to verify the file, you need to
Correct.
separately,
Correct.
which you cannot do
Directly via payload, you mean. But his point is that payload is already encrypting and doing all hashing. Why you are doing it at app layer?
So
Right? Is that your?
This is your essence in approach, right? So, there can be malicious file also going. So-
How will you validate?
Yeah.
Correct.
Because it will not verify whether it's a malicious file or not in the transit. It will just verify that, what you sent is what you received.
Correct. And SMTP works as the app layer protocol, right? Any simple mail transfer protocol that you follow,
Yeah.
right, across the TLS layer, across HTTPS will go by app. So I think that's the reason that app will first validate, then the payload will get encrypted.
The SMTP encryption is a big, because if you look at it, whenever you are doing anytime you're sending passwords encrypted, that's another reason why you want to encrypt it at
At
the
the app layer, right? Yeah.
And then encrypt it at the transport layer to ensure that there's no man in the middle sort of a thing who can read this and extract that.
But his point was-
secure channel and a secure message.
Yeah,
Two
both.
things are slightly different.
Yeah.
Because you cannot be sure that the channel security is always there. So you ensure that the
Payload.
message payload is.
Correct. Yeah. That's a very well said, right? Whatever you're sending via transport layer is actually the only payload. How do we validate the authenticity of it? From an app layer, I think that's your first signal to the system that you will have to do the hash, and then the other caller, receiver, will also do from the app as well as from TLS is anyway getting done.
And SFTP browser is not using, right?
The final protocol of sending an email will eventually be done, right? It will only initiate.
Any file upload.
Huh.
It is going to be SFTP.
Any file upload which is going to be, I mean, you mean outside browser?
Yeah, I'm sending a file to
Huh.
somebody. Loading.
Huh.
So it's not going to be.
Not all the time, correct. But for a browser point of view, it is always. You mean if you're doing from an app client which is non-browser, non-web view, is that?
That could use that.
Huh.
But browser will not use SFTP.
So we use it, but I do not know whether it still is being used in after TLS 1.3, but we use it. Because there's a lot of code base only for FTP. Yeah.
There's FTP, there's FTPS, and there's SFTP. So there are
Yeah.
slightly three different
So maybe
variations of that.
that's the reason, if browser is also using that protocol, maybe TLS layer is not in function at that time.
TLS layer will eventually come at the end, right?
Yeah.
May or may not, it all depends upon how the system has been developed. If you're not even doing the certificate-based thing which requires SSL/TLS, then it will just be plain text, right?
Yeah, it would be, I mean, that
On HTTP, you can always send whatever you want. It's not necessary.
HTTP will never block you, right? But a typical production payload will always never use HTTP. Right?
Should never happen.
Should never, yeah. That's the statement. Okay, so guys, this is Bloomfilter, which we use. Database, we use very heavily hashing. Hashing is also used to create the index and all, guys, right? Whenever you want to, for any column that you want to do hashing or indexing. Guys, how many of you know what is indexing in a database? People know, right? Yeah, so basically, can somebody help me, guys? What is indexing in a database? Correct, faster search. How does it help? Does it actually store the location of the record? It is actually, right? Yeah. So it stores the location of the record. Say, for example, how do I put it? Select star from employees where email ID is equal to some email ID, right? If it is without indexing, you will have to scan every single row and figure out what email matches with whom, right? So if my record lies after, say, 1 lakh, I will have to eventually scan 1 lakh to reach the data. What indexing does it? If I know my query is always on an email field, I do the indexing of my email column. So that, and indexing with sorted, obviously. I mean, you will have to do binary search and all on top of it. But the idea is basically give me the data of this column then and there, from the first O of 1 normally. Right, so-
Just to give an example, how you typically look in a dictionary, if you want to look for E, you go to the index page and find which page number is that.
Correct, correct.
So that way, that makes the search.
Correct. True. And indexing is normally an expensive operation because it ends up taking your hard disk for sure. And second thing is, we will still debate a lot of maintaining work. Maintenance, you'll have to do an index, right? As in when your data gets changed, deleted, or anything happens, you'll have to update your indexes.
Excuse me. I have two questions. Like Redis also has some hashing algorithm.
correct.
Based on which algorithm, any idea?
You mean Redis?
Yeah.
Sir, I will not know which actually algo because is a Redis You mean the open community edition wala code base? No, I haven't seen that code base.
And also the database sharding,
Huh.
that also has some hashing.
In sharding. Sharding basically what record will go into what node? Is that what you're saying? Distributed. Yeah, they'll always use that. Correct. But it is most likely that any databases will only use, I assume, it will be either MD5 or shard. People will not go for murmur because that breaks the analogy of a safer D. Right. Mostly. But I do not know which will go. Okay, now comes the encryption part of it, guys, right? So one is a hash, right, which we understood. Now, we have, sir, how much time we have? Okay, guys, are you hungry?
No.
I'll take 15 more minutes because I wanted to cover one more important concept and then we'll wrap up. Encryption, guys, right? So you know, hashing is never meant to be very secure, right? I mean, you get an input, you get a hash value, and that's it. You are done. It is never meant to be reversible the other way around, right? But encryption is where you want to get the actual data back. That's what encryption means, right? Encryption and decryption. Now, there are two types of encryption. Guys, anybody want to help me? What are two encryptions? Symmetric and asymmetric, and everybody uses two names very common. You know, Alice and Bob, right? That you see across, guys. I see it across all the books, across example, and across LLM answer also. Okay, so that's a good sign of that why LLM still uses Alice and Bob, right? So this is basically asymmetric and symmetric, guys. Symmetric, where am I? This is symmetric and encryption. Symmetric means if I want to send data from X to Y, I have my own private key. I will encrypt with that private key, send it to you. You will also use the same private key to decrypt the data. That's what symmetric actually means. So both of you, me and the recipient, always have the same key, right? The good example of a symmetric key is, which is a good example, guys? AES, exactly. Advanced Encryption Standard. AES is one of the most popular ones which is being used. TLS uses heavily AES code base that you will see it across the browser. So once the connection is established and private key is shared, we switch to symmetric encryption. Same private key across both the guys. But the question comes, right? If it's the same private key, I will have to share the private key. Somebody has to generate, and then it has to send to the other machine, right? How will I do that?
Certification.
Through secure channel.
CA.
CA, certifying authority. Okay.
Key distribution protocols.
Which one, sir?
Key distribution protocols, RSA, Diffie-Hellman.
Oh, okay. Nice to generate a key. Okay, so sir is pointing to Diffie-Hellman wala algo. That's a nice. But say for example, I want to just send a private key to you, right? And how do I send it? The same private key.
You
give a USB.
I give a USB to you that my key is inside this. Use it, right? Nice. Yeah. What life would have been very simple. Yeah.
Send it by post.
Correct. Correct. Bharat was there in my last talk, so good man to listen. This thing is simple, right? In symmetric key, the only problem is everything is good. Okay, it is fast. You use the same private key, but the only problem in symmetric is how do I send the private key to you? We both are on two different worlds, right? That's what asymmetric solves it. We'll quickly move into asymmetric. This is symmetric. This you can, okay. Asymmetric says that I have two private keys. One is here, then there is also public key. Okay, so each caller and a receiver will have its own private key. Both are different and they have a public key. This guy, sender will also have a public key, receiver will also have a public key. I will quickly show you, I think. So this is a diagram that I have. I got it from LLM only mostly. And you got a plain text, you converted it to a ciphertext. How did I convert this? I got a public key of the other party. The message that I am sending to whom, right? His public key is what I got. With this public key, once I encrypt a message, can I decode myself? No. So I am a sender. You can't, right? Logically. I took his public key. How did I get his public key? He gave it. How? No, but there will be some system, right? Who will give me public key?
Key exchange protocols, right? Key servers, key exchange protocols.
Key exchange protocol, correct.
Key servers are there.
So there is something called SSL certificates, right? Secure socket layer certificates, which you see. There is something called certifying authority agency also. which will say that if I am creating a website called, say, for example, google.com, I am actually the Google, right? I am the enterprise who owns this. They will validate that you are actually google.com and they will put the signature saying that, okay, your certificate is valid, you are a proper Google Wala enterprise. Now what really happens is from a browser, we will, when we do a handshake, we will ask them, give you a certificate in the very first attempt. This is TLS 1.3. The other guy say, okay, take my SSL certificate. In the certificate, there will be public key. That's how I validate. The moment your certificate is tempered, you will see on a browser connection is insecure. That comes from our code base. Right? So whenever you see either somebody HTTPS is not using a website, a certifying certificate, then also we throw up the dialog. At the same time, so a lot of people do bypassing of Trust Manager. Right? I'm sure all of you will know that if I want to send an I trust all SSL certificate in my life, we write a code of Trust Manager Factory and tell them that accept all SSL. Have you seen it? In internal, when you build an internal app, right? And where you say that I want to build HTTPS only, but I do not want to take headache of validating that certificate. In that way, you will always say that since my code base is running within the private network, I trust all SSL. That's a wrong way of doing it, but since you are running within your firewall or within your private network, it is still okay. Right? Why we do it? Why we bypass that certificate? Otherwise, browser will not let you to go into the actual website. Browser will block you. That's the only reason. Because we have a say that if you are using HTTPS and you do not have a certificate, we will block you that in there. That means something has been tempered. Right? That's the reason people use a trust manager to unblock. Okay, you got a public key, you encrypt it, you send the data to via secure channel. What is a secure channel means? Or insecure? I mean, it is a TLS layer normally. If you are calling HTTPS, it is a TLS layer for us, which is actually a secure. But why we put insecure here normally? What if this layer gets compromised by somehow? Okay, is what the point we are saying, that even if somebody is able to decrypt the data out of it, he will get a public key and the payload, but he will never have the recipient private key. So he will not be able to do anything out of it, the system. That's the whole point. That even say, for example, if I am sending a data to you, with your public key I encode, right? But only you can unblock that. You can only decrypt the data. Right? If somebody else in the vicinity gets the payload, he cannot do anything until he has the private key. Right? That's the whole point. Now, what really happens is this, right? So you have a data which you are sending it with his public key, and the other guy is also doing the same thing. Right? Other guy also have my public key. Whatever data he wants to send me, he will use my public certificate, get the public key, encode it, and send it to the system. Right? Now, what's the problem here? Is it slow or fast?
Asymmetric is slow.
Slow, right? It will always be slow. Why?
You have to get the
There
public.
is very large numbers.
You need a very large
Numbers, very large integers, factorization, and all the.
for having a public key.
Yeah. For public key, private key, you are using very large numbers because mathematical operations are extremely
Correct, true. The numbers are very large for sure. The second thing, why it is because both of you, sender and recipient uses a different private key, guys. So whatever you do, you will have to decrypt the data with your own private key. That process also takes time. And whenever you encode, you will again have to encode with the public key of other party. Got it? So that's the reason asymmetric is normally slow. But here, what is the problem? If you see, we are saying this guy is slow, the other guy is fast, but other guy have a problem of sending a private key. Now, what world has figured out? Can anyone help me? So, you know that we have to use only symmetric. But in symmetric, you will have to solve the problem of how to share private key. Asymmetric is asymmetric letting you to do that?
Yes, the symmetric key is generated and use asymmetric to send it across both parties and then they use it.
Correct. So, say for example, right, what really happens is the first part of the transport layer is how do I send a private key? So, I initially started with the asymmetric, it generated my private key, put in the payload, encrypted with his public key, send it to the other guy. Once other guy also received and decrypted with his private key, he also has his private key. I also have my private. He knows he knows his keys and I know my keys normally. Now, once you know the key, you can switch to symmetric LOs. right? That's what. So the idea was initially start with the asymmetric, right? Share the private key via the other guy public key. So other guy also knows now private key of a sender. Okay, now both have a same private key. Once both have a same private key, switch to symmetric. Every payload transmission that happens via symmetric. Did I make sense? Right, you understood it? Okay, let me quickly move in. So, okay, now RSA and all we have explained. Now, okay, this is guys the simple table between symmetric and asymmetric. Symmetric is identical key, asymmetric always uses two different keys. Right? It is symmetric is always fast. So the idea is guys, everyone in the world have understood that to send a data, symmetric is the way. The only problem in symmetric is sharing a private key, for which I ended up using asymmetric. So if somebody tells you what code does the browser uses, it's always two different systems, symmetric as well as this. No, people cannot say that I only use symmetric. No, it always starts with asymmetric, then we jump to symmetric. Okay, this we will all know. Okay, now I will go into use case of symmetric and asymmetric. Yeah, one is transport layer that we explained, databases, right? So obviously encryption is also used in databases to integrate the validity of or authenticity of a record, especially in distributed systems. Sharding, one of the very common use cases where in sharding they want to figure out that what payload will go into what node. That works via this. Right, so and where each database will use its own technique of how do we put encryption and hashing, but typically in a distributed system you will see this very often. The third is VPN banking, which is banking anyway for sure. Right, so okay, this is for TLS guys. I will not take it because we are running out of time. One thing which I want to cover up quickly, right? This, as what Sir said. Diffie-Hellman protocol, guys. These are the standard protocol. Anyone have idea what this protocol being used for?
Generate symmetric keys independently. So we start with two numbers and there's some operation that goes on which I forgot. We come up with the same key at the same time independently.
Correct, exactly. I mean, very well said. So it is basically the idea is guys sharing a private key. So you understood, right? Somebody has to generate a private key. But the problem is still same that I will have to share the private key to you, right? What if I really do not want to send a private key to you directly by any means and still you will be able to figure out my private key? Is this confusing? How do I share my private key? Now say for example, I'll tell you one simple example. 2 plus 4 is equal to 6. Say for example, 2 is my private key, which I never want to share. I will send the other party 4 and 6. The other party can do 6 minus 4 and get the private key. Is this correct? Right, so you send a simple equation, the other guy knows what operation he has to do and he will do the from the max, normal max. Yes.
How many such copies or how many instances of these private keys are created? Like I'm assuming that every time there's a symmetric key exchange, every client gets a different.
Yes. How many types of keys can system create?
Yeah.
Is that?
I'm guessing these are not stored centrally on some server. Different instances.
We are running out of this. Is okay. To answer your point, the system will reuse a lot of existing keys. We'll run out of it for sure. System will use because by the time session is already closed. Right, so it is only maintained until the session is live. After that, we'll end up. There will be a lot of keys which will continue to get repeated for sure, given the number of instances are very high. Okay, Diffie-Hellman, right? What it says, guys, I want to share the private key. How do I share? If I tell you 2 plus 4 is equal to 6 and I give you 6 minus 4 as the caller, he will still be able to figure out 2 is a private key. That's a good case. But then everybody else in the world will also be able to figure out the simple max. Right? So what max says, mathematics says, can you create an equation which is irreversible? In maths, this is solved a discrete logarithmic problem. Okay, where you say that I will give you some parameter From that parameter, you will never be able to figure out the third parameter. Impossible. That is how the discrete maths is being used. Now, what is, okay, I will just quickly tell you. Protocol, this you already know. This I will get into the diagram. So guys, what this guy says, right, it's a very nice pattern. You got three numbers, 5, 2, 10. Correct? 5 I will call G, the power of I will call A, and after mode I will call it P. Now what it tells is G to the power of A mode P. That's a discrete law. Base to the power of mode A, base to the power of A and mode P. So for example, if I do 5 to the power of 2 mode 10, 5 into 5 is 25, 25 mode 10 is 5. Mode is reminder, right? Remainder? Remainder. Right, so similarly for these numbers, 2 to the power of mode 3 is equal to 1. Now what it is trying to say you guys, you have three data set here. You got base number, you got power of, you got mode, after mode, right? What if this number is a huge prime number? Okay, and what if to the other party I only send this data to as well as I send this data, but I never send this data. So base is what becoming a public key. After mode, the value of P is becoming a public key, but I never send the 2 to the power of that power, right? That I am not sending it, and I am giving this calculation to the other party. Now I will explain you how does that really works. Okay, now listen, this is the most important diagram and this is the final. Let's get it. Client. What client says, if you look at it, agree on G and P, right, which we saw. G and P is what both parties agree. So G and P is will be shared. P is a prime number and G is a primitive root mode P. Okay. Now let's see what really happened. Now this guy takes a private random natural number A. What it takes is, it takes the A. This is a number. It also has G and P value. It creates the sum of it. What it does is, it calculates this value. Okay, remember A is a private key, rest everything is a public. Only A is a private key. What we are sharing is that I am not sending you A, I am giving you everything else. It calculates this value, and this value is what sends to this guy. This guy also do the same operation, guy. It takes his own private key, okay, and it sends the it does not do anything, it sends the G and P again back. Now what this guy do is, it takes his sum of G to the power of mode P and it supplies to the column. And this guy takes the sum back and apply his private key on top of it again. See this, I think for a second you will understand. Because this is a pure maths, nothing else. What it really means is, G to the power of BA is actually equal to the G to the power of A to the power of B. That's where your whole private key calculation resides only on this logic. So if I send you my G and P and I never send you A, right? System will, and this guy have its own another private key. He will take this checksum and he will append with his own private key. That he will calculate. Is this making sense? Yes. So this is slightly difficult, maybe in one attempt, but what we can do there, I will share you one example, probably that will work. Okay, let's say one example, right? The same person, Alice and Bob. Oh, Alice is a lady, eh? Okay. Alice, you got A equal to 4, right? And what he did is, remember, that's his private key. Her private key, sorry. I calculated 5 to the power of 4 mode 23. Now this 4 is the total, the final value of that calculation. 4 is what I am sending to this guy. Okay, what it did is, it also has its own private key, 3. I took 4 to the power of 3 mode 23 and I calculated the sum. So the private key turned out to be 18. And this 18 has never been shared on the channel. Now you can ask me that what if somebody gets G and this mode P value, can he not derive the power of value? No. It is easy to derive for a small number, but for a very prime number, this calculation is very difficult to break. And that's what mathematics relies, Diffie-Hellman relies on generation of this algo. Now this is a very fundamental algo guys, right? In today's browser, do we use this directly? No. We do not use directly this. Okay, now why you can always say, because it is possible if I apply every single brute force, at some point I will be able to break it. Okay, but what browser also says that by the time you figure out, we anyway reinitiated the session. So you are done. Now people ask me that quantum computer will be able to break it. The answer is yes. Quantum computer can still break it. Very easily. Okay, because these are just classical computer problem guys. Okay, because you got play with bits here, but if quantum operates same simulations of two states together, it will be able to easily calculate. Okay, but since we are not up to there, this works still. Now everybody in the world, right, today, say for example WhatsApp does not use Diffie-Hellman directly. They all have different algos which is built on top of Diffie-Hellman. So the fundamental is still same, but they created in such a way that these values are very giant. Okay, these are 10 digits, 12 digits, 15. I have seen 21 digits. I don't know how because 21 calculation will be very tough even for machines, but people use that. So it makes your system slow, but it makes other party to predict your private key impossible. Which machine? Yeah, it is. Correct. Yeah. Very good. Correct. Because the calculation can go very huge. So this is where it works, guys, right? And I'll not go on top of it now. Any question on this? Diffie-Hellman?
No.
Browser uses it, all encryption parties uses this kind of algos. They don't use exactly the same, they use the second version of it. But the ideology is same. Yeah.
Man in the middle attack is still possible in
Man in the middle attack in this algo, how?
No, I am asking the question.
Or is it possible? So if somebody is able to figure out the value of A, okay, by doing some sort of max calculation one by one at a time, okay, it is still possible to break if the numbers are small.
No, so let's say there is a heap drops in between.
Huh.
Now there is two Diffie-Hellman going on, one from A to E and one from E to B.
So Diffie-Hellman will go only from 1 to here. The other guy does not have to generate Diffie-Hellman back. Acha, you mean the middleman will continue to attack. If you impersonate yourself as a valid, authentic server, right, and you do, is it really possible?
If the channel is
The other chips is
correct, the channel is
on that.
So what we are saying is if you are not using HTTPS, is it possible to break, right? Is what you want?
No, it's not directly that. It's if someone is impersonating as a CA, or you can say it's not very specific to browser.
Okay.
It's on a protocol level. These are the basics. If someone is behaving as a Bob, so he would be able to get all the information since he is sitting in the middle.
So you mean he also has his CA certificate? Is what you're saying? So certificate will always block you to connect with the impersonated servers, right? Because he will never have that actual certificate what Google and the other parties have. So the moment your certificate is not valid, or you are saying that I am a Google, but you are sending me a certificate of your own or which is not signed by Google, I will tell you are not Google. So browser will block you then and there. So this we will not come to that concept at all if first level itself is blocked.
So if the certificate gets shared with friends and both friends are requesting the same thing, it is going to be break.
If can you repeat?
Certificates, like I have a certificate and I written the certificate to the team.
So what you are saying is I am pretending to be a Google.com is what you are saying, and I will say
You are Google and we have the certificate only. Now we are going to communicate. And later, those certificate I have provided to the teams to communicate with you.
Okay.
That way.
So you mean you are then again you are pretending to be Google, right? Is what you are saying, because you have moved that certificate across. So when we hit your website, right, metadata and all the rest schema, and your CA tells you that your domain name is this, but your CA certificate is different, browser anyway will make it insecure. Browser will not let you know.
Makes sense.
Right, so at some point, I mean at first point itself, that's the reason without HTTPS cannot do anything without certificates. Those certificates are mandatory and we are not signing that certificate base. It's say for example, in India I see most of the people sign that by Verizon or Norton. Norton is heavily used to sign the certificates. So you say that I become a Norton and I sign those, so that becomes something called a self-signed certificate. Which browser anyway say that we will not let you to use self-sign until you say I trust the certificates, all. Got it? That's the reason people end up writing a code saying that yeah, browser is blocking me, can I unblock browser, and they write a code of trust manager saying that trust everything coming from any server. Then we will not block you because you have written the code like that.
Good alternative is the Let's Encrypt today, which is certificate.
If you are running within your own network, okay, you can always do self-sign. Right, so okay, that's it all from my side, guys. I have a lot of other stuff, but I will not take it. OAuth is something which, so OAuth, I'm sure many of you will know, OAuth actually uses TLS 1.3 security, guys. Okay, so, but I will not go deeper into it, but you have to remember that there are a lot of protocol which is only built on TLS 1.3 or 1.2. Because they trust the underlying infra, that's the reason security is being bypassed to the third layer. If you ask me if TLS 1.2 or 1.3 was not there, can we still do a OAuth? Impossible. Right, so that's all the thing, and the key takeaway I will put it, right.